So today is the 28th day of the LeetCode 30-day challenge, and the problem will be first unique number. So we are given a queue of integers, and we need to retrieve the first unique integer in the queue. So we are asked to first initialize the object and then show first unique, where the first unique is defined as for all the numbers in that queue. We must find for all the unique number in that queue, we must find the very first element that we inserted. And then add is insert new value to the queue, nothing special. So this is basically a very traditional LeetCode self-defined data structure problem. So how do we solve this? Okay, and this problem will solve via 3 data structure. The first one is we will use a unordered map integer to integer, where this unordered map is used to count the frequency. So the key is number and value is occurrences or frequency. And the other unordered map is map integer to list iterator. And the key is still number, and the value is the position at the linked list. And finally, the list integer L. So you might ask, why do we need the linked list for this problem? Okay, because this is actually very simple. Whenever we inserted, the linked list is defined as the unique queue, where the queue is the FIFO data structure, first in, first out, or save, first serve. So if the unique number is like list, this 1, 3, 5, 10, and then all of this is unique, and this is the list first, front, back. So this one is show first unique. This is the object that show first unique must return. And linked list gives us the constant time for the front. And you might ask, oh, we only have this one, but why we still need? Because vector can also get this power, because vector front is also a constant time. So why do we need the list rather than vector? Because if we insert 3 to the queue, not the unique queue but the queue, then 3 is now duplicated. And since 3 is duplicated, if we use the vector, then we need to first search at that vector, and then we then delete it, or say erase it, and use vector to find and delete takes the linear time. Since the query is greater than or equal to is up to 5 to the 10 of 4 power 4, then the ON will definitely get time limit exceeded. So we must use linked list, because when we want to remove something from linked list, like this one, we simply just need to modify the pointer. So modify the pointer in linked list takes only the constant time, which is very inexpensive. For example, 235, the initialized queue is as this. So we have linked list like 2, 3, and 5. And number of occurrences will be 2, 3, 5, and their frequency is 111, and number of position at linked list 2, 3, 5 with their corresponding iterator as value will be 2 point here, 3 here, and 5 here. And then we have, for example, when we add 3, then because the frequency of 3 will be increased to 2, and once the frequency is greater than 1, then what do we need to do? We will map to the NL, and NL get 3, and 3 is the key, and the value is the corresponding list iterator, and we will get the list iterator in constant time because it is a hash map. And then we use such list iterator here. We have the list iterator, and then we can erase it from the list very fast because we no longer need to find, and we simply give the modify of the pointer job to STL. So we just need list erase for O1 because we already have the list iterator, and it is that simple. And if we want to find or get first unique, then we only need to first check size first, and then return list dot first, or say front. Okay, it is that simple. So now we jump to the coding part. And this is the NL map number value to the linked list position or list iterator and list int L. And then when we want to add a number, and if the frequency of such value is greater than 1, then it is duplicated. And if it is in the linked list, because we have such iterator, so the key exists in it, and linked list is not empty, then we can simply get the iterator and erase from the linked list. And so does the map, where map the number to their corresponding list iterator. So NL must to be erased as well. Erase value and else L dot in place back value, and then L value equals to L dot end but end is nothing, so we need to minus minus to get the last element. And then return L.size. If the size is not 0, if the size is 0, we return -1, otherwise L.font. Because 0 means there is no unique numbers now. And there's no unique numbers now. And that X. Okay, let's see if this works. Okay, so that's all. See you tomorrow.